Welcome back. In the previous video, right, I've drawn a circuit specially to find common mode gain, right, and shorted both V1 and V2. That was I was trying to explain. Both V1 and V2 are same because that's what I was saying, right? V1 is equal to V2 is equal to VCM. Instead of saying mathematically V1 is equal to V2 is equal to VCM, physically you can short both of them and then vary your common mode voltage. Then you look what is the change in V01 or change in V02 because of VCM. Either one of these two. Don't say V01 minus V02 to find common mode gain. That is not the gain definition. The common mode gain definition is one of the outputs, either V01 or V02. What is the change in V01 because of change in VCM, or what is change in V02 because of change in VCM? That is what is our common mode gain definition. If I take that, okay, I can erase all these things. I've never used this for AC analysis. Okay, that's fine. I will not derive again. There is a way we need to replace with each parameter model to find, but I will not do that. I can write in a different way. Now, can I don't know, is it confusing? No, right? Both are shorted. V1 is equal to V2 to VCM. Okay. Now, if you see this, can I write the circuit something like this? If you see here, can I draw the circuit something like this? Just listen here, don't write. Can I write like this? You tell me, this is your RC, okay? Or what I mean, okay, let me draw here, that I'll do here. Then this is what is your transistor. Just listen, don't write, okay? Can I write that RE as something like this? Two parallel resistors, but each is 2 RE. Can I write like this? And this is what is our, let us say, inputs. This is your VCC, right? RC. Don't bother about all these things, okay? This is your VCM, and this is your VCM. Common mode voltage. This is your V01 and V02, right? Now, can I write like this? Then what is this current? This is what is your current. Let us say this is what your I bias, and we know this is nothing but I bias by 2, and this is I bias by 2. Then what is the current which is flowing through this? Again, KCL. I bias by 2, and this is I bias by 2. Right? Now, can I draw again the same thing like this? Now, the same circuit. Now, the next one. Now, this is nothing but 2 RE, right? And this is your VCM, and this is what your V01 and RC, and now this is VCC. Similarly, this is 2 RE, okay, and then RC. I'm just separating power supply, and this is V02, and this is your VCM, okay. Now, but there is a short, okay, there is a short. I'm just splitting into and writing like this. Now, what is this current? We know that this is I bias by 2, and this is also I bias by 2. Then what is the current which is flowing through this? I bias by 2. Then what is the current here? I bias by 2. Then what is the current which is flowing through this wire? 0. Then can I take it out? If the current is not flowing, it is simply but shorting and then saying that both the voltages are same. Yes, but there is no current, you can take it out. If you take it out, then because the current is 0, you can say the current which is what is flowing through this is equal to 0 ampere. There is no current because same current is flowing. In series, current is constant, right? KCL is satisfied and there is no current. If there is no current, both are same. Then can I write this circuit is nothing but what? This is individual. Now both are individual. You can say Both are individual circuits. When both are individual circuits, tell me what is V01 change to VCM change? AC. Therefore, what is your common mode gain for this? Is nothing but the change in V01 divided by the change in common mode voltage VCM. Right? Therefore, what is this? This is nothing but what? CE with RE amplifier voltage gain. CE with RE amplifier gain. What is CE with RE amplifier gain? Okay, I'm just taking mod ACM now. Common mode gain is equal to what? RC divided by 2RE. Because this value is very high value, practical current source resistance value, or the practically we will take RE value very high in the differential amplifier. Therefore, RC divided by 2RE. Either you can take this or this, anything is fine. Or delta V02, the change in output voltage divided by, both are same, basically shorted, but the change in the common mode, both are same. Therefore, what is your common mode gain? Common mode gain is equal to RC divided by 2RE for the practical differential amplifier having RE value instead of tail current source. Okay, take it. Differential gain. AD. Right? Now, just listen. This is your V0 what? V02, V1, V2. Okay. Now let's see. We have DC voltage. Let us say common mode voltage. Then because of that, whatever current you have, this is let us say IC, and we have IC. Then here, let us say this is I bias due to the emitter voltage VE. Okay. Now this is what is I bias by 2. I bias by 2. Now this is also I bias by 2. Now, and this is what is having IB. This is having IB. Therefore, now fine. This is what your DC. And with this I already explained, right? Done. Now, let us say the signal whatever you want to amplify, differential gain, right? Apply differential manner. Now, your input is increasing, then your VBE is increasing. Let us say your IB is increasing. Then here it is decreasing, your IB is decreasing. Then your IC is increasing, let us say it is increasing by delta. IC is decreasing by delta. I bias by 2 plus delta, I bias by delta. Then what is the current which is flowing through RE? Same, doesn't matter. Remember, in the case of differential gate, whether it is a current source or a resistor, practical current source or ideal current source or a resistor, doesn't matter. Why? VE is constant. Because VE is constant. If VE is constant, this is what is called as AC ground. If this is constant during AC analysis for the AC signals, this is ground. Ground means again two common emitter amplifiers. Then the differential gain AD. Therefore, for this the differential gain AD is equal to your CE amplifier gain. CE amplifier gain. Therefore, if I take mod AD is equal to HFE into RC divided by HIE, or this is not GM into RC. This is what is our differential gain. And if you ask me, CMRR is not infinity, which is nothing but AD by ACM, because ACM is not 0 for this practical differential amplifier. But the differential gain is independent of either current source, ideal current source, or practical current source, or a resistor. Because the VG is constant. If VG is constant, then it is treated as AC ground. Okay, take it. Then I'll give you a summary. With that, it is over. Therefore, when you apply the input, what do you want to amplify in a differential fashion, then it is accepting. The resistor RE is not coming into picture. Because the voltage across the resistor is constant, the current through the resistor is constant. Therefore, it is AC ground. Then you apply in a differential manner. But remember, ultimately we got AD is equal to HF into RC into HIE. But there is another analysis where people say that don't apply any AC signal, keep it like VCM, but apply only AC signal here. There also, if you calculate V01 minus V02 or V02 minus V01 with respect to V2 minus V1, then you get the same thing. I am not explaining that part, but you get the same. Therefore, if you are getting the same, why to invest more time here? Okay, that is fine. Therefore, I am applying in a differential manner. Then, what is differential gain? That is what? Therefore, again, what is the definition? AD is nothing but change in V01 with respect to V1. Sorry, AD is defined as V02 minus V01 or V01 minus V02 and V1 minus V2 or V2 minus V1. That is nothing but our AD, where AD is nothing but this is nothing but V0 divided by small vd. V0 is nothing but V01 difference to V02 or V1 difference to V2. Okay, summary. If you take ideal differential amplifier, people call it as diff amp. Anything is fine. As far as you know that there is differential amplifier, that is fine. Therefore, what is ideal differential amplifier? Is a tail ideal current source. This is with I bias, right? Now this is V1, V2, V01, V02, RC, RC, right? Now for this, if you ask me the common mode gain is 0 because of tail current source. And what is differential gain? The differential gain AD is defined as, or let me define, this definition is nothing but, okay, not okay, we already defined. AD is nothing but what? Your V01, okay, that is nothing but your CE amplifier gain. right, which is HFE into RC divided by HIE. Okay, everything let us take magnitude. Then the third one, CMRR is defined as mod AD, everything is taken as magnitude, right? Then this is infinity because ACM is 0. Now if you take practical differential amplifier, right? Then what is your common mode gain? Your common mode gain magnitude is equal to RC divided by 2RE. If RE is very high, your common mode gain is very low. Okay. Number 2, differential gain AD is equal to CE amplifier gain, which is HFE into RC divided by HIE. I am taking simplified model. And third one, CMRR is equal to mod AD divided by mod ACM. Therefore, this is not infinity. That if you substitute, you will get it. Okay. Therefore, tell me whether you use current source or whether you use resistor. Do you need capacitor? Right? We don't need capacitor. Therefore, now if I can say direct coupled, now the last one, direct coupled differential amplifier. Let me give you the practical. Okay. For the practical, simple minus VGG, if you give dual power supply, right, then VCC, RC, whatever you get here, small V01, there is no DC signal because you will get average 0 only, and this is your small V1 and small V2. We don't need any capacitor. Now whatever 0 voltage you give, that itself is bias voltage. 0 voltage itself is bias voltage. And your output voltage also start from 0 because let us say 5 volt and then minus 5. Let us say this is 5 and this is minus 5, then it is starting from 0 0. It can start from 0 0. Therefore, this is what we are expecting. Let us say here in this case, let us say this is 10 volts and now this is 0 volt. Therefore, both are same. Therefore, this is what is direct coupled. And then if you ask me the frequency response of this amplifier, right? Now this is differential gain only because we are looking for only differential gain. We want to amplify the signals from differential input. Therefore, the frequency response of this is improved. This is what is the frequency response, which is nothing but what? HFE into RC divided by the value. HFE into RC divided by HIE. This is what is the value. Now you got like low pass filter. Your low frequency response is improved. That is what is the one. Therefore, completely your low frequency response, right, improved due to what? Due to dual power supply and differential amplifier. Because we don't need to bias the zero voltage itself act as a bias voltage, which is common mode voltage is 0, and no need to block the output DC voltage. The zero voltage itself is your DC or bias voltage at the output. Okay. Therefore we got it like what? Therefore now can I say the definition of op amp, direct coupled, yes, direct coupled, we don't need any capacitor. High gain, if you take output of this and then give it to one more stage, you will get very high gain. Differential amplifier, this is differential amplifier. The first stage of op amp is differential amplifier. Now can I say your definition is satisfied, but I'll explain a little bit about the gain stability, the op amp gain stability, okay. Then with that one more concept will come. With that I can say op amp is over, then directly we can go for applications. Okay. I'll stop now. I think this video is short because I want to complete the differential amplifier. Then I'll start again the op amp, the stability point. Then we will see the remaining things later. Okay. If this is done, fine. Otherwise you can pause the video and you can write down or you can note down. Okay. Thank you.